All right, time to get started here. Okay, so this week, I guess I should just say Happy Friday to anyone who's listening right now. Um, so this week, I'm going to be sticking with the same theme here, which is loading Arweave data into Crux. And I did this last week, and I suspect I'll stay on this for a while. I mean, for a variety of reasons. One, um, it's nice for me, if, as long as I want to keep doing these streams, to have a theme. It just reduces the amount of planning and figuring out like what am I going to stream about every week. Two, I think this is kind of an interesting thing, and it's the thing. It's the thing I'm most interested in talking about and like helping people learn about. Um, yeah, there's a couple angles to that. I guess I should unpack. So I'm really interested in getting people to understand, and actually for myself too, just understanding how Arweave works better. Um, and I have a decent amount of experience with databases and functional programming, and so sort of the intersection of databases, functional programming, and data immutability is just a really interesting space for me. So, excuse me, got some allergies here. Um, so working on combining those things and loading the data structures into a database and doing interesting things with it, I think is a good way to explore Arweave's data structures, cover some database stuff, get people more exposure to Clojure, hopefully, get some exposure going both ways. There are Arweavers interested in Clojure, Clojurists interested in Arweave, and people interested in immutable databases interested in all those things. So I think it's an interesting space to explore. It also is not. It's not on the critical path for the distributed mining pool I'm working on, which makes it nice for streaming because I can put more. Yeah, I can be a little more consistent. I don't have to worry about quite as much about if I'm making progress on this in the meantime. So I can put more of the actual development content into the streams as opposed to, just covering whatever I happen to be focused on every week for the mining pool. And I think it's also probably one of the more interesting things for people watching too. So anyway, that's my rationale, and I'll probably stay on this for a while. I think the initial use case here is I want to get data into the system for my own analytic use cases, and I think once it's there, you can start to do some other interesting things. Like you could have a few different ideas. I don't want to talk about all of them, but like one thing you could do is start to build a gateway implementation. And there's one or two out in the community already, but I think we could probably use more of them. And I think building one completely in Clojure would be pretty interesting. It'd be nice to get a little bit more uh, JVM based tooling for Arweave. So yeah, let's see. Is there anything else I wanted to say before I start here? Just going over my notes. I think that covers most of it. Um, yeah, I do have a few other things written down here, but I think I'll just dive into the code and we can talk about them then. So just a little refresher for where we left off last time. I did a little bit of work in the meantime, but nothing that's earth-shaking here. I'll cover it. I have a little bit of background noise here from my family here. Hopefully you can't hear that. Um, or you find it entertaining if you do. Okay, so I think last time I got as far as loading a block. Actually, yeah, we loaded a block and some transactions into Crux, and I still have our very hackish REPL code here. Um, in the meantime, I wrote a couple of utility functions. This is all like super work in progress, so don't take any of this as like best practice or how it's going to be in the final version. But just a little utility that takes a string, converts that to bytes, just using the Java base64 URL decoder. Um, so if you remember from, let's see, I have a good example. Yeah, let me just get a block here. We can look at it. So this is our Arweave block. At the end here we have the chunk, which is ginormous. But before that you have sort of a mix of these things, which are base 64 URL encoded bytes, some numbers, and let's see, yes, here's one. And some numbers encoded as strings because this is way too big a number to fit into a integer in JavaScript. So we're only get 53 bits for integers in JavaScript, so and this is way bigger than even 64 bits anyway. So yeah, it's basically a mix of binary data, base 64 URL encoded numbers, and then numbers encoded as strings. So I should have left that up. Yeah, so this takes the base 64 URL encoded string, turns it into a byte array, and then I have a start of a Mali schema for a block. So I have streamed a little bit on this in the past, but it's been a little while. So Mali is a sort of schema specification, a data-driven schema specification language for Clojure. And there's a few of these for Clojure. There's schema, there's spec, there's Mali. Those are the ones I could think of off the top of my head. I don't know if they mentioned any others, but those are the main ones. You know, if you're from JavaScript world, JSON schema is sort of vaguely in the same space. The reason I'm picking Mali, other than like, ooh, it's new and shiny, is it's the specifications are represented as data, and that means you can save the specifications and manipulate them very easily, as opposed to spec where I think this is the same in spec too also, but there's no native data representation of spec, which means it has pros and cons, but that means you can't save it or manipulate it quite as easily. Mali also has another reason for using it is has built-in coercion support, and it's my understanding that spec 2, well, it's not really a goal of spec to do data coercion. So that is definitely something we want, and you know, another feature of just having data-driven specs is we can do things like generate JSON schema from that. So anyway, just a little recap there of why I am going with Mali. That said, I'm totally not an expert on Mali. I've used it a little bit in the past, and I'm interested in learning more. So do not take anything I'm doing here as like Mali best practice. I'm still kind of learning, the grain of the library and what's idiomatic in it and what's not. Yeah, I expect this part to evolve as I learn how Mali works. Okay, so what do I have here? I have 3 schemas. So this is just a schema for representing or describing base 64 URL encoded bytes, and this is one for the big integers, so the string, the integers that are encoded as strings. And the way this works is Mali supports describing the encoding and decoding. So right now I'm just describing the decoding in here, but what it's saying is we have a JSON decoder that when you want to convert from JSON coming in into whatever the native data types we want inside our application, use this. And if you want to support going the other way, which I do, but I don't care about yet, you'd have a leave, I think. Let me double check, make sure, because I haven't actually used that yet. Yeah, enter and leave. So we're not going to worry about leave right now, but it would just be the opposite. You basically take a encoder and encode the bytes. So these are just little schema snippets, and then you can just place them into your block schema, which is sort of the schema for the whole block, and they'll do what you expect. So let me just demo this real quick. So yeah, okay, have some code here to do this. Okay, so I will evaluate this, which is just going to pull in. I just randomly pick these blocks. There's no significance to them, so just going to pull in that block. And first, let me print out I'll print out the block. I always like to dissociate the, spell it right, dissociate the proof of access just because it's a really big thing to print and it messes with Emacs if I don't. Okay, so that looks like this. The only little bit of munging that's been done is I let the my JSON parser take the keys and turn them into closure keywords, which is really not. It just makes it easier to manipulate in closure. There's not a lot of reason to do that other than convenience. But that means I can do things like this, where I just say, or the better example would be, so like timestamp. You know, just get the timestamp out of the block really easily by using keyword. Yeah, so there's just some nice affordances using keywords in Clojure. That's the main reason I do that. Okay, so this is without any of the schema applied. So let's go ahead and apply the schema and see what that looks like. So this will decode the original block, that's just the name I'm using for the lightly munged block that we've loaded directly from Arweave. We're going to apply or decode it with the block schema, and then we're going to use the JSON transformer, which just tells it to do transforms that that are relevant for JSON, which is why we said decode JSON. There's also a string transformer, but it makes more sense to me, right, based on my current understanding of Mali, to use a JSON transformer. So that's what we're doing. Okay, so let's try that. All right, so now you can see I haven't completed the schema, but for most of the things, we're decoding. Now it's a little bit deceptive here. In the decoded version, this looks like it's a vector of integers, but it's actually just a printed representation of a byte array, a Java byte array. So just to prove that to you, if we go in here and we'll get the, doesn't matter, I'll just pull a hash out and do class. Yeah, so that looks really funky if you don't know how these things print, but that's a byte array. Let's see, what does type give me? Same thing? Yeah, same thing. Okay. So, yeah, take my word for it. That's what, that's the class of a byte array. Okay. So I think the thing we're missing here, yeah, let me back up for a second. So that's kind of where things are right now. I have schemas here. Debating a little bit. I noticed in the Mali docs, I'm still trying to pick up what good idioms are for these things. One thing that they do in here is they, what's a good example? Yeah, this is good. This is a schema right here. And they often do whatever case that is, that camel case, whatever. Snake case, no. Anyway, they capitalize them like you would types in Java. That's often, just to show you. So in Clojure, you mostly use this kind of kebab case thing, where you use dashes between words. But for things that are types, this is completely unrelated code. I'm just using it as an example. Like if you do a def record or something like that, you capitalize the words. So I don't like these trailing schemas everywhere. It's just really ugly. So I'm going to try this. One thing that's a little iffy about that is here I have so there is just like a big int type, I think. What does that give me? Big int, unable to resolve. Really? I wonder, does it resolve, does that resolve? I would think so. Interesting. Okay, it might not be a problem then. I was thinking that was, what is that? Java.util.big util? Tangent. I mean, I know if I do this, so let's do class. Oh, Java lang. Okay, fair enough. I think we'll probably fine just calling that big int. So yeah, let me go through and do that. So we'll just replace big int schema with big int. And then we'll replace b, what am I doing? B64u schema with base 64. We'll just keep it short. I may change that later, but it's kind of verbose if I spell it all out. Yep. Okay, and we'll call, we called that block. So now I also need to do block schema. Oops, schema. Oh, did I change all of those already? No, I did not. Okay, yeah. Block schema with block boot. No, just one of them. Okay, I could see going back on this, but for now, I think that tidies things up a little bit. Again, just sort of wandering through the space of Mali idioms here. I'm sure I'll settle on something over time. Okay, so yeah, I got a tangent on my tangent here. So things I would like to do ideally today is have a function that takes a block and takes a block and generates a crux document from it, takes a transaction, generates a crux document from it, and then takes a block, fetches all the transactions for that, the Arweave transactions, I should say. It takes a block, fetches the Arweave transactions, from all that generates a crux transaction. I may have to have some extra words in here to disambiguate between Arweave transaction and crux transaction, but we'll see. I'm not sure how bad that will be. So just the schema itself, just like a complete schema, is almost all the way there to generating the crux document. Let's see, I think I also have, yeah, I have a block. Let's just pull this up. Let's put this, I guess I'll put this right here. Just thinking a little bit about how I want to represent this. So again, the way, I mentioned this in the previous video, but just repeating a little bit. Ultimately, I think what's going to happen here is I'll have some of the block data stored twice. I'll have the parts that I want to query on stored in like a metadata document, name TBD on that, but that's sort of a placeholder name right now. And then I'll have the document that contains the block data, but without the fields of it indexed. And the way Crux works, all the top level fields are indexed, and then anything that's nested is not indexed. And that's, I would not be, let me get this out of the way, I would not be surprised if that changes and they give you more control over the indexing in the future, but that's the way it currently works. So I think what we want to do here, just thinking about what fields we would actually want at the top level. So I don't think we want that. I do think we want height. You want a little bit of indexing because you need to be able to retrieve these to do things with them, but you want kind of the minimal indexing necessary. I don't really think we want the timestamp. And then we're just going to save the raw block. So I think what we want is the indep hash. That's the independent hash. So yeah, there's two hashes on the block. There's the independent hash and there's the hash. The hash is the one that includes the nonce, and that's used, in the consensus to prove that you've done the hashing to clear the difficulty. And then the independent hash is actually the content hash of everything, of the non-varying parts of the block. And so the blocks are addressed by the independent hash. So I think at the top level, we want to store the independent hash, and I think we want to store the previous block and the height. And then we want to store the block. I think that makes sense. I don't think we care about the timestamp at this level. My reasoning here is, okay, if we have the independent hash, oh, actually, do we need that? Do we care? I think, I don't know. Maybe not, because we already have that. That's in the ID. This should be, oh, interesting. So let's keep it for now. So the one thing that's interesting here is the yeah, interesting. So yeah, I should verbalize more what I'm thinking here. So when we decode the block, everything's going to be converted to bytes. And the database IDs, this is wrong. We're going to use, I'll just put that there for now. Independent hash. So if we don't, it's already going to be a string. I'm doing a really poor job describing exactly where I'm going here. I should call this like raw block, maybe. Raw block. Yeah, so let's do this. Okay. So just explain a little more what I'm thinking here. So when I do the coercion, which let's pull this up here. So we got, ooh, no, stop. I'm not sure what keystroke I'm hitting there, but it really messes things up. Okay. Completely derailed my train of thought. Okay, so yeah, there we go. Block. So it's the original raw block, the uncooked block. Yeah, so this is what I'm calling the raw block here is the block that we receive that has not had any munging done to it except the keywordization of the keys in the JSON. So we're going to take the JSON, convert the keys to keywords. That's the raw block. We'll pull out the independent hash, which is still a string, and we'll take that and we'll use that as the database ID. And the database's IDs are like unique IDs for documents, so they have to be globally unique. So we namespace it with Arweave block, put the independent hash on there. So that's our DB ID. Then we take that, we decode it, that turns into our block. So now all the stuff in there is like big ints, big ints, longs, or byte arrays. And then we can start to use that version to fill in some of these other attributes. But because this is a string, I think it actually would be kind of useful here to include the hash as an attribute in addition to having it on the ID. So it's like a little bit of extra space in our indices, but I don't think it's that big a deal. There's only, I think Arweave gets about, it's targeting, I think like 744, is that right? Block every 2 minutes, it's 700 something. Should look that up. One day, what is that? 720. 720, there we go. Yeah, that's where I was getting 44. Okay, 720. I think in practice it gets around 900 blocks a day because it's based on difficulty adjustment, and sometimes the difficulty adjustment lags a bit. So you can get more or less, I suppose, if the difficulty was dropping. But it's mostly not what's happening right now. So anyway, yeah. So there's not a ton of blocks, so having a little bit of extra data here isn't going to kill us. Yeah, so let's do, order doesn't really matter. We'll say that. So let's pull the keys out that we care about. So we'll pull out the, oh, this is interesting. Well, let's do this. If I pull out the independent hash here, post decoding, it's going to clobber the already bound version. So we'll do this. Just pull that out of the block. And these other ones we can pull out here. Trying to decide if I like that. I don't really like the way we're doing that. Let's do this instead. So we could do the other kind of destructuring. We could do that, and then this, oops, this becomes boop, independent hash. So this is independent hash string. Oops. Okay. So we'll call this one, I could do kebabs there if I wanted, but meh, I don't know. I'll leave it for now. Not an important decision. And then this one, we can just pull out indep hash. That's a little better. So let's call this indep hash. Okay, so we're still missing something in the schema, but I think this gets us a block to dock function. Let's try it. So, ooh, what did I do wrong here? No symbol block. Oh, I must not have reevaluated my schema. All right, there we go. Okay, block to dock. So let's try, we'll take this. Let's do orange block. And then do block to dock. And then we still dissociate the proof of access. So does that work? Looks like it. Let me pre-print that. All right, looks pretty good. Not too surprising. It's not doing anything too fancy. Yeah, so these top level things here are what we'll index on. And then we have here, just nested in that, the block itself. And I don't know, I'll just stick with this naming for now. I would not be surprised if at some point I prefix this a little differently. I'm not sure. Like I said, there's going to be 2 documents for every block and every transaction, at least. There'll probably be extras for transactions for the tag mapping. But I don't think I know well enough what I want to call them yet. So we'll just stick with that. It's kind of a placeholder. But the intent with this one is it's more of it's the thing that stores everything and it has fewer things indexed, and then we'll have another one that has less stored in it. It's not complete, but has more things indexed, and they'll be linked together by the hashes. One thing that's important to point out here, so the way I'm thinking about doing this, because we're going to have these 2 documents per block, the raw one, the one that has all the data, is going to have IDs by hash, and the other one is going to have IDs by height. And my thinking there is so if there's a reorg, you can have a chain that gets built that then gets abandoned because it's not the longest chain for whatever reason. There can be reorgs on the blockchain. And when that happens, the mapping between height and hash shifts because it's different blocks on each chain. In that situation, for querying the canonical data, you don't care about those blocks that have been abandoned, but I don't see a reason to delete them, and they could be useful to refer to. So we'll still have them, but only in the sort of raw form. Don't know if that made sense the way I explained it, but I think it should make the data size, and especially the index size, a bit smaller, but you'll still have the original blocks there to get to if you want them. If you want to sort of explore the history of these chains that have been abandoned and reorganized. Again, all kind of TBD in terms of how it shakes out in the end, but that's my current thinking. Okay, so we're still missing one thing here. So we have these transactions, which is simply an array or vector in Clojure speak of, oopsie, oh no, did I kill my Emacs somehow? Oh no. I don't even know what caused that. I've been semi-frustrated with Emacs recently. I use evil mode, which is like Vim key bindings in Emacs. I've been a little bit tempted to abandon Emacs for NeoVim, but haven't pulled the trigger yet because it's also kind of a waste of time to explore that. But let me kill this. Let me really kill that. And we'll just get back there. What I probably should do is debug Emacs more instead of abandoning it. Because well, that's a whole tangent. I don't want to go there. There's a lot of things I like about it, but there's a few things that are frustrating me quite a bit right now. Okay. Let's get back here. Get that. Ooh, did that not? There we go. That block retrieval may have taken a little bit there. Okay. So, oh no, dang it, I did it again. Okay. I'll see if I can avoid that this time. I think it's when I'm trying to go to the bottom of the buffer, which I kind of do that without thinking. Though I don't know why. Oh, I know why. It's because yeah, okay. I removed the proof of access, but now that I've nested the block, it's actually not removing it from the right space. So I gotta adjust my dish there, and that will fix that. All right, apologies. Let me probably make some helpers that just make sure I always do that. So, all right, let's try that again. At least this time I know what's going on. Okay. So before I do anything, let me dissociate in. Is that not a thing? That's not a thing, is it? What's the best way to do that in Clojure? Oh, I could do update. Yeah, that's what I'll do. I'll do update, Arweave block, and then dissociate. That'll work. I bet. Let's just check. Medley. So there's a various people have little utility libraries for Clojure. Yeah, that's what I thought. So it has a dissociation. They try to just fill what they view as gaps in Clojure's standard library. I might pull one of those in at some point. Not right now, though. Okay. With some luck here, get my block loaded again. That's taking a long time. Why is it taking so long? There we go. Okay, got that. Got this. Okay, that looks more promising. Whew. Okay, sorry about that. Okay, so yeah, schema for transactions. So transactions, let's see. What do we have? Vector? Default 1, 2, 3. Yeah, so it'd be like a vector. I think we just do this. So we have tx, and tx is a vector, and it's a vector of b64. Yeah. All right. Ooh, did not. Oh, tx's. Helps if I put the right key in there. Okay. Oh, and there's no open web boundary, so I can go a little bit over. I'll try not to go too much over. I think these get a little ponderous if I go too much over an hour. So, but we'll see how far we get. So this looks like a fully realized schema for the current block format. See, is there anything I'm missing? Arweave, HTTP, API. Get the block. All right, so, block format, here we go. Oh, it's stuff like tx root and tx tree. I got tx root, not tx tree. I forget if tx tree. This will be interesting. I'll try to get this figured out before next time. So I think there's still. Yeah, I'll just stop talking. I'm not sure exactly what tx tree does there. I think. I think tx root is the main thing that's used these days. Might be a little bit of legacy stuff in there still from previous ways that the chain was used. Also, I think data. Oh no, data would be on transactions. That's right. Refresh this. And again, that page has a similar property to loading up the proof of access in Emacs buffer. It likes to kill the browser. Transaction format. Do they not have? Interesting. Oh, there it is. Sample transactions. Okay, well, let's go ahead and get the transaction format going here. So, actually, before we do that, let's just get started on the thing that makes the transaction, the crux transaction, I should say. So that would be, we'll do block to tx. I'll just say crux tx. I may abbreviate it in the future, but this will keep it clear, you know, for the stream here. So we're going to take a raw block and we're going to do block doc. So that's going to be block to doc, and I'll take the raw block and return the document. And then what does our transaction look like? I don't have this completely ingrained in my head yet. Okay, so we want a put and then the document, and then there's two optional things here. So Crux is interesting. It's a bitemporal database, which means it has two dimensions of time, transaction time, and I think they call it valid time. We don't really care about that yet, so I'm just going to leave off valid time, and we'll just insert the document as is. This lets you say that a transaction or a particular document is valid for a particular, starting at a particular time or for a particular window of time. And ultimately, I think this would be kind of cool to include a timestamp here for each of these, you know, that corresponds to the block time. But it's not important right now. Just lets you do fancier temporal queries. It's actually more relevant in a system where you can, you know, quote, alter the data, but in a blockchain you can't really alter the data. But it'd still maybe be neat for the like history of the chain itself. So when you have reorgs, you could say, okay, this block. That might not work though, because it's like a branching history, and you really, with valid time, you really just have a linear history. So I don't know. Yeah, at the very least, you could say when blocks are valid from, and just use the block time for that, and that might give you some affordances in how you query the data. But anyway, so I'm going to do a crux.tx put. Ooh, wow, does it complete that? I don't even know. TX. Wow, interesting. I wonder where it gets those. Well, whatever. I don't actually know how Emacs does that. Okay, and then here, I guess I don't need another line for that. We'll just put block doc. Okay, so this is the start. I'll just put it to do here so we know that to do retrieve Arweave. Okay, so retrieve the Arweave transactions and create, I'll say, Crux documents for them. Okay, but this is a start, and let's see what Crux. Yeah, let me just pull this in. So this file is getting very messy, but that's okay. So we'll say let crux tx is block. We'll just dep that actually, since we're just doing REPL stuff here. Oopsie. Yeah, so we'll say this def crux tx is the block to crux tx of the orig block. My terminology is getting a little munged too. I have orig block and raw block. Wait, don't I have the node? Did I not def once? Oh, it's down here. I'll move this up just so my Blender doesn't complain. How do I save the disk? Yeah, I'm not gonna worry about that now. It's actually nice to save. I only have it in memory while I'm playing around. Okay, so where are we at here? We have the crux tx. Let's just pretty print that. All right, it looks okay. I did eval this, right? I think I did, yep. Okay. And then we're going to submit the transaction to the node, except that has the thing coded in there. I'm just going to do that. Okay. And let's grab our, sure, just grab a query so we can sanity check, make sure things are getting in there, okay? So we want, let's just say, just placeholder here, and then the indep hash, and actually ID maybe. Let's do that. I'm not sure what you end up with in that position actually in Crux if it's the document ID. All right, so let's eval that. Just sanity check here. Okay. Okay, yeah, that the first thing is actually the document ID. All right, looks good. So we have a document in there. We're pulling out the document ID and then the independent hash, which is our byte array. So it looks like everything's round tripping as expected. Okay, so the next thing up would be to make a schema for the transaction. The milestone here, I don't think you'll get this complete in the stream, but my thinking is once I have the the schema complete for the transaction and the block, and I've got the raw data in there lightly indexed, it's just a lot easier to make progress because then instead of going out to, I can start loading that data as is into Arweave, or I'm sorry, into Crux. And once I have a lot of data loaded, I can manipulate it by pulling it from the database as opposed to pulling it using HTTP from an Arweave node, and that just should speed up iteration on the rest of the schema. And I'm sure I'll have to even then I'll have to do more than one iteration of this to probably get the base schema right. But that should speed things up, I think. Okay, so let's go ahead and call this tx. Okay, so what do we have? Let's look at our original block here. And actually, while I'm at it too, let me just go through orig block, just make our terminology consistent. So do. All right, grab that. Yep. Yep. Okay. Cool. Oh, I have one here already. Okay, that's cool. So I don't need to. Is this one of the transactions that's in that? Let me double check that. So. Yeah, okay, so it is the first transaction from that block. Yeah, let's just go with that. Raw tx and raw tx. Okay, so let's def that. Okay, so what do we have here? We have tags. Tags is a vector of maps, and yeah. So mostly all the same kind of stuff. You know what? Let's go ahead and tackle tags first because that's the thing. That's the thing I need to look up here. So I guess I probably know everything I need to for that. So this would be another map. Delete the extra junk. No. So vector has a vector of maps, and then in the map we have name, and that would be B64U, and value, which is also B64U. All right, so the vector of maps. Yeah, let's see if that does what we expect. So we'll take this. Don't think I evaled it yet. I'll eval it in just a second. Okay. So we have the TX and we have the raw TX, and we're going to put it through the JSON stream. So I'm going to say eval the buffer. Let's eval this guy. Let's see what we get. Ooh, why is it taking so long? That's concerning. Oh, it actually, I must have named something wrong. Yeah. So this, I neglected to put the name of the thing. This is one thing that is a little bit, because everything is just like vectors of vectors in the schemas, it's easy to make a mistake about structuring things because, I guess I'll do that. Maybe. I don't know. I don't know. I don't know what the best way to structure these things. It's really easy to make a mistake about how you've put together your schemas because it's so uniform looking. Uniformity makes it easy to manipulate, but then it also leads to that problem. To be honest, I don't fully understand why they went with this. Why they didn't make some of these things maps in here. Maybe they wanted to preserve the order. Um, in case, I guess that could matter. Like if you wanted to generate something like Avro from these things, the order would matter. So anyway, I don't fully know the rationale, but it does have that unfortunate side effect that it makes visually it makes your schemas a little bit harder to read because everything looks so similar. Um, okay. Okay, that looks like more like what we want. We got the byte arrays in here. Format. Yeah, actually, let's look at that. So format, there's two. Currently supported formats are 1 and 2, often referred to as V1 and V2. V1 format is deprecated, so it doesn't actually go into what the V1 and V2 are. To get into a little more detail on this, some of this stuff, looking at the Erlang code is the right thing to do, but don't think we'll go that deep down the rabbit hole this time. But that will be ultimately like, there's that TX root versus like TX tree. TX tree, maybe that's something from an old format. I don't know, but anyway, that's where you answer those questions as far as I can tell. Let's go with Erlang code. Okay. All right, so we got tags. Let's just keep going down the list here. I can probably knock this out pretty quickly, and then maybe. Yeah, I think we might be able to get all the way to creating a complete Crux transaction that has all the transactions, the Arweave transactions, and a block in a single Crux transaction in this stream. I think that's probably doable. So let's see if we can get there. So format would be mm, mm. Oh, you know what? I think I may have left out. Well, it doesn't really matter. So this would be a hint. I may have left out the non-big int values here, so I may have to go back and add those, but that's fine. It still comes through as the right thing, even though I haven't put all those in the schema yet, because it just passes through stuff it doesn't know about. Okay, data format. So this will be 64U. I'm not going to narrate all of these because they're all similar. Let's blow through them quickly. Reward. ID. Last TX. I wonder is that the previous? transaction? That's interesting. I didn't know. Let's see, does that say here? Anchor, a protection against replay attacks. It may be either a hash of one of the last 50 blocks or the last outgoing transaction ID from this. If this is the first transaction, then an empty string may be used. Interesting. Protection against replay attacks. Let's think about that. Okay, target. It's going to be another address, which would be empty for data transactions. Quantity data tree. I'm just going to leave data tree out for the moment. I need to look at those trees in more detail and see exactly how that's used. I think the sort of quote correct way to use this these days is have a data root, which is the Merkle root of the data. But again, I need to dig into the Erlang to understand what those trees are doing. Okay, B64U. And then, oops. This is another thing I'm not sure about. So if you retrieve, what's the data size here? Yeah, I do not know when you get data here. If that's just a convenience that's there for very small data, or if that's actually a distinction in how, like, between the different versions of the transactions. But yeah, so this is illustrating part of why this is useful for me, because it really forces me to look into the details more of what's going on here. And ultimately, that's a big part of what I want to learn is, the really nitty-gritty details of the protocol. Okay, let's evaluate this again. And we'll go down here, try to decode this thing. So if this all went well, oh no! You know what? I'm just going to leave that one out for now. It's this guy. Oh, that's because it doesn't need to be a keyword. It should be there we go, predicate. Boom. Okay, data root. Did we miss data root? We did miss data root. How did I do that? Okay, fine. Fine. Data root. That should definitely be bytes. Anything else in here is missing? Looks like not. Okay. Should be sufficient to create documents. Yeah, just quickly sanity check that. All right, I don't want to go too much over here because, again, I think these just get sort of tedious if I go too long. And I run out of words too. So, okay, so what do we need to do to sort of wrap this thing up? Okay, so first thing would be raw tx's would be doseek over, so we'll call this txid. And then we'll want to doseek over tx's in the block. No, we want the for. I think this will work. So closure is eagerly evaluated. However, it has lazy sequences. So if I do something like for, any side effects that happen in the for, well, what comes out of the for is a lazy sequence, and the things in the for are not evaluated until the sequence is realized. So if I have side effects in there, they're not actually evaluated until I realize the full sequence. I think that would be okay in this case. We'll see, because I'm actually going to be doing HTTP requests in there. It's probably not the final form this will take, but you know, get it working first and then make it good. So get tx by hash is my little helper function. Oof, I did not mean to go all the way down there. By hash txid. Guess this should be raw block, right? Not block. Okay, raw TXs. So that's going to get me a sequence of the transactions, and I might be able to do this all in one go here. So let's just do TXs. So we'll get the raw. Sorry, I got a notification on my phone there. It's distracting me. Got the raw block. TXs. Map. Get TX by hash. By hash. Wow, I'm. There we go. That thing. So we're going to map that over all the transactions. That's going to retrieve us the raw blocks. And then does decode work in a pipeline like that? Don't know. Does it? No, I don't think it does, because it's got the thing at the end. Oof, how do we do that? Yeah, that's an interesting one, because it's oh no, it still works. We'll just do this because we got a map over it anyway. So we want to do this. So we do map, and then this is going to be anonymous function, and then we just throw the thing in right there. Okay, let me do this. Let's see if that works the way I think before I mess with it. This will probably take a second because it's actually going to go out and fetch all those blocks. I'm sorry, all those transactions, Arweave transactions. I probably, yeah, I should, I might not have liked, let's do this. Let's just do like a take 5 out of that. Or no, let's just do 2. That tells us that we're getting multiple things, but it's like minimally abusive to the Arweave server. Although chunking might mean, you know what? Let's do it differently. Let's do it up here. So we'll take 2 out of there before we even retrieve anything. Try that. Yep. That looks better. Okay, so did we get? Yep, there's one. There's another one. So I suspect what's happening is I might be getting rate limited if I try to do them all in a loop like that. It would not surprise me at all. That looks good though. Okay, so let's take that, and then we just need to construct the transaction from it. So, oh, you know what? Okay, we still have to do this. We have to do the tx to doc function. So I don't know if copying that. Let me not. Copying that is not really helping much. Yeah, let's just start with we're going to do tx to doc, and we get the raw tx in. Okay, so what do we want to pull out of there? That really is unreadable once you convert it to the byte arrays, orig or raw tx. Let's see, so ID. Okay, interesting. So we'll take keys ID out of the raw tx. I think actually we want to do this the same way, so we'll call this ID just for consistency. I think I'll probably end up making these kebab cased, but so just for consistency we'll do that. That's consistency with the thing above. Okay, so that gives us the ID. Then yeah, copy this thing. So we want to do transaction. We're going to decode the raw transaction and then pull some keys out of that. So we want the ID. Anything else? Oh, you know what? We want to take in, well, I think I'll maybe, I don't know if I want to do that on the stream. We'll see, To do, I want to have the block. So we need something on the transactions that links them back to the block that they're on. But we don't actually get that. Let's do this. So, yeah, I may defer that one. The thing I'm debating is I'm not really sure how you want to pass the block ID into this. It makes me think that maybe I should be doing this in 2 steps. So decode outside and then convert that to a doc and then pass the decoded block into the tx to doc. I'm not sure. I'll have to think about how I want to structure that. Okay, so let's keep going here. So we want the ID. Is there anything else we want to index this on? I think not. So again, this is trying to get just the raw data with sort of minimal indexing so you can traverse it and find things, but not necessarily pull much out. So let's do, so this will be, so this is Arweave TX, and then here we have ID sir, we get the DB ID, and then we generate and TX, boom. Very interesting. Okay, so that looks right to me. I'm pulling out the ID string. I'm going to use that to make the DB ID. We're decoding. I'm going to pull out the ID, and then we're going to add that onto there. Yeah, I think that's reasonable. You know, one thing I was debating as I was looking at this, you could do something like we could namespace these. So it's like Arweave block/height. I may do that, but actually I'll add it to do, so include block hash/ID, and then on this one, namespace top level keys, maybe attributes, whatever you want to call them. Okay, so let's take this and we'll replace this thing with tx doc. Oops, tx2 doc. So, all right, evaluate that, and we'll call this tx docs. Just sanity check 2. That's tx2 doc. Oh, and I'll just for testing purposes, we'll just do the take 2 in there as well. Tx doc, and yeah, let's see what that does. Cool. Looks good to me. Okay, so now we should be able to. There's a couple ways you could structure this, but I think for now I'm going to do it this way. So, maybe so do this. Yeah, I don't know. This is not the most elegant way to do this, but and then we'll concat. Yeah. This is kind of an inelegant way to code this, but should do the trick for the moment. Tx docs. All right, block to crux tx. I think I have that. Let me. So block to crux tx. Yeah, first let's just see if we're getting a sane transaction out of that. If anything stupid there. Okay, so we got the block. Really, no matching item? Oh no, did I kill Emacs again? Stop, Emacs, why? Oh, it's because, yeah, I know why. It's because now I'm not pulling the proof of access out of there again, so we have a giant. Ah, man, that kills me. That is something where I'm pretty sure Vim would be okay. Because, I don't know, Emacs has a hard time with really big buffers. Vim does not struggle quite as much on that. Okay. So I should munge that a little bit before. I'll just drop the first thing. Okay, let's try this again. Connect to the REPL. Okay. Okay, and block. Where my block to? There we go. So this, yeah. Let's evaluate that. Really, it was that fast? Oh, probably because the lazy sequences didn't actually. So let's just do drop 1. So that should drop the doc and just give me the transactions. Yes, success. Yeah, it looks good. Okay, so let's try. Um, Now, if I run this query currently, I should get nothing. So we'll submit the transaction. All right, so this should give me the same. Yeah. So I got the block and the byte array hash, and let's see. So if I do, I think namespacing those keys would be good because it would disambiguate. So like right now, I mean, I know that the ID is only in the transaction, but it's a little bit ambiguous what the heck I'm talking about here. So yeah, so this should give me two things, and it should be the document IDs for the transactions, and it should be the hashes for the transactions. So let's try that. Nice. So this is pretty good. Okay, yeah, I think I'll wrap up here. So um, yeah, there's definitely tweaks to make here. I do think namespacing these things is the right move. The only hesitation I have on that is if it will increase the key size in the index. Um, I think that's probably still worth it, and Crux might do some sort of clever encoding on that. But you need to be able to sort the keys, I think. So I think I got to look at the details. I think overall, even if it does increase the index size a little bit, it's fine. Fine for the clarity. Uh, and then we also need to have the block hash attached to the transactions so that we can query across them too. But otherwise, this is pretty good. So we get a block. Um, I guess I could do a version of that function too that just takes the block ID and fetches the block in there too. I probably will do that. It's pretty good. So we take the block, we retrieve the transactions for it. Let me make a note. I am doing this to do unlimited TXs. Do need to take out that limit, which probably implies some kind of rate limiting. Although I can hit my own servers too, and I won't get rate limited. I'll just kill my servers. That's probably the route I'll actually go. Um, yeah, my servers are not. I have limits on my servers in terms of bandwidth, but not actually in terms of HTTP requests. Although eventually I'll have both. Anyway, yeah. So we take the block, we retrieve all the transactions, and we create a Crux transaction from that. So that's pretty good. I mean, there's some bits of schema that need to be filled out too, but once you're there, and you can pull in all the transaction and block data, you don't have to fully understand it as long as you can later, as long as you can later manipulate it. It's like getting it in sort of its raw form into the database feels like step one to me, and then from there on, iterating should be much faster because you have it in the database. Um, yeah, I guess the next thing after this, I want, right now this is all just doing in-memory stuff. It needs to be stored somewhere too. Um, and my plan is the way Crux works. It's got different components. You can do transaction. You can put the Crux transaction log in different places. You can put the document store in different places. And then indexes, there's sort of different formats, but they're usually local. So I'm thinking I'll probably put the document store in S3, the transaction log in DynamoDB, because it's not going to be like high volume transactions. It's just going to be basically one transaction per block, in terms of Crux's transactions, not in terms of Arweave transactions. So the level of yeah, I think that should be fine. The level of transaction volume going through Dynamo will not be so high that it causes any problems there. And that will be super convenient because I can refer to those. I can easily load data from those either locally or out in AWS, and I don't have to manage any of those components. Yeah, so let me wrap up here. Yeah, thanks for joining the stream. I hope this is entertaining. I think I'll know these streams are really successful. I don't know. I don't want to say successful because they're out there already and people can watch them, and I think there's some value in that. When I get people complaining about them, though, that's when I know I've achieved some level of I don't know, viewership. when people start to complain. So, but I haven't had that yet. So that's a future milestone. All right. Yeah. Thanks for joining, and I'll see you next week. Probably same kind of topic. I imagine I'll do a little bit on this in the meantime, but probably not too much. You can pick up where we left off. All right. Talk to you all later.